Guillaume from Université Laval.
We have Guillaume coming here.
Yes, I'm here. Can you hear me?
Hi, Guillaume. Yep, we can hear you.
Perfect.
Just reset my timer. And if you can start whenever you wish.
Yeah. So, hi everyone. My name is Guillaume. I'm working in Laval University. Today I'm going to talk about my work in dispersion of graphene polymer composites for printed electronics. So first of all, we want to use graphene for its interesting properties. One of them is a very good electron mobility that allows applications in printed electronics by the use of conductive graphene ink. To make those ink, it's necessary to have quality graphene in huge quantities, and this can be achieved using liquid phase exfoliation or LPE. It's a cheap, scalable method that produces high-quality graphene. The principle is to immerse graphite in a solvent or in a polymer solution and apply a force that can exfoliate the graphite into graphene layers. The resulting material is then stabilized by weak interactions. The problem for the industry is that LPE usually requires toxic high boiling point solvent such as NMP or DMF. This is why our research group is focusing on alternatives using conducting polymers. You can change the slide, please. Thank you. So we use azulene as a building block. This molecule is very interesting because it can increase the conductivity of the ink. Furthermore, the synthesis is quite adaptable, and the conjugation of the molecule allows pi interaction with graphite. We are doing a Suzuki coupling between azulene and various conjugated blocks with solubilizing lateral chains. And in this way, we have a conjugated polymers with good solubility in low boiling point solvent that can also make steric interaction with graphene layers. And you can see here some of the polymers we have designed and synthesized, and I'm currently working on a protocol to disperse graphene with our new materials. So if you have any question, I'd be pleased to answer. Thank you.
That's great. Thank you very much. A great talk. Were there any questions from the jury?
I'm not seeing any questions come in on the chat.
Okay, I do have one. I know this kind of liquid exfoliation process. I did some research on it myself in the past, and I'm a bit out of date with it, but I know there was a lot of people kind of looked and found that it introduced a lot of defects sometimes into the graphene layers. Do you have, what kind of methods do you use to quantify the fact that you actually get graphene out of this?
So first we use Raman to see if we have a lot of defects by the D band. You know, you have G band, D band, and 2D band. One of the band increase when there is defect in the graphene. Other way is to see if we introduce oxidation during the process. And to do that, we do FTIR to see if we have graphene oxide in our materials.
That's great. Super interesting. And sound like, yeah, excellent choice of techniques to test. Great. Thank you very much for your talk.
Thank you.